Today we're going to apply it to word problems. So ironically, there's only one example, but we'll go through. It has 3 parts in this lesson. So applying the binomial distribution. So nothing is new today. Okay, we're still using the same formulas or tables that we used yesterday. We're simply going to apply it to word problems. So starting with example 1. So here's the formula again, so you have it. Okay, we're going to start here. It says a burglar alarm system has 6 fail-safe components. The probability of each failing is 0.05. Find these probabilities. So if we have 6 of them, okay, we want to find that exactly 3 will fail, fewer than 2 will fail, or none will fail. So first of all, we're going to write down the values that we need. Our n value is 6. Our p value is 0.05. Our q value is 1 minus 0.05, which is 0.95. And then we plug into the formula. My n value goes here, and so 6, then 6 minus 3 factorial, okay, and then 3 factorial because 3 is my x value, 0.05 to the 3rd power, okay, because 3 is my x value and 0.05 is my p value, times 0.95 to the 6 minus 3, okay, calculator all of that, and I end up with 0.02. So there's a 2% probability that exactly 3 will fail. Right, now let's look at fewer than 2. Now, when we're talking about fewer than 2, we have to define what are we talking about. All right. So first of all, my n and my p and my q are still exactly the same. Okay, fewer than 2 means that I will have 0 or 1. I will not have 2. I will not have 3. Okay. So when we talk about ors with probabilities, we're talking about a plus sign. So I'm going to use the formula right here. All right. And I'm going to say, what is the probability that 0 will fail? All right, and I'm going to plug everything in and do it and in my calculator, and I would get 0.735. That's the probability that 0 will fail. I also need to find the probability that 1 will fail, and again, plug it into the formula, plug it into my calculator, and end up with 0.232. Now I have these 2 probabilities. It's a probability that fewer than 2, so it's either 0 or 1. It doesn't say or in the problem. You have to extrapolate that. The idea if fewer than 2 will fail, then I know 0 will fail or 1 will fail. It's not that both, all right? It's either or, because I can't have 0 fail and 1 fail. So 0.735 plus 0.232 will give me 0.967. So the probability that less than 2 locks will fail is a 97%. That's a pretty good percent. Okay? Then part C of example 1 is that none will fail. Okay, so what's the probability that none of them will fail? And actually the answer is already on this one. It's on the next slide too. But we have it right here. We've already calculated it, that 0 will fail, and it's 0.735. But we can look at it on this slide too. Okay, so 0.735. Once again, plugging in the numbers in a formula. All you're doing is using a formula. The hard part sometimes is deciding what all of my values are. All right. Oops, I put that page in there twice. Okay, so here's a practice one. So that a survey from Teen Research Unlimited found that 30% of teenagers receive their spending money from part-time jobs. If 5 teenagers are selected at random, find the probability that at least 3 of them will have part-time jobs. Okay, so let's talk about this. I'm going to have you guys do the work for it, but at least 3 of them. Okay, if we have 5 teenagers, that means we're going to have to find the probabilities for 3, 4, and 5. And then at least 3 means that we'll have 3, 4, or 5. It's not that they will all have part-time jobs, but the probability that 3 or 4 or 5 of them will. So go ahead and do your calculations. And here's your answer. And I will see you tomorrow. Short video today.